So the multiplication of polynomials is gonna add some more terms here, and it's gonna start to become a little more complicated. But let's start off by using our algebra tiles. So the rules say basically the first factor, this thing here is the first factor. Goes on the left, x plus 1. And what do we have on the left? Basically x plus 1. And then the second factor goes on top. This is x minus 2. And then fill in the grid with tiles that have the same height as the tiles on the left and the same length as the tiles on top. So, right, if we have two x's, we're going to wind up, when they're multiplied, with an x squared. And then these are going to be these rectangles here. And I'm coloring them in because, right, the product of two tiles of the same color is positive, but if they're different colors, it's negative. So these dashed lines mean that these are basically negative x's. And then this here is going to be a positive x. And then this here are going to be negatives. So, and you might want to try using algebra tiles to do this. In fact, I'm certain we're going to have some worksheets using algebra tiles and doing this multiplication just to give us this practice we need. So when you're all said and done, you wind up, when you combine all these, that you have essentially x squared, right? And then you have a positive one, right? This is a positive x, and this is a negative x. And well, these two cancel each other out, right? So then you're left with a minus x minus 2. And that is in fact the answer if you FOILed this out as well. And foiling is just another way you can multiply these, which we're gonna learn in a little bit here. Some of you might already know it. And this is section 5.2. And this next section is just a reminder, right, that the negative and the positive canceled each other out, and you were left with basically 1x squared minus x minus 2. So now that we've solved that one, I'm gonna expand on this a little bit, and I want to have enough room to write. So here we go, and I'm gonna erase this stuff. And here's another way you could solve these things if you weren't solving them via algebra tiles, is if you were to distribute, right, this x and this plus 5, well, here's the x, and here's the 5, right? Here and here, well, that's x plus 5, right? So basically, they've just taken these terms, and they said, well, we're going to take this 1x, and we're going to multiply it by this in parentheses, and then we're going to take this 1,5, and again, multiply it by the other stuff in the parentheses. So when you do this, it kind of splits up the work sum into basically two parts. And this is a lot easier to distribute, right? So let's try and give it a shot. So you basically have, well, x times x is going to be x squared, and then x times 2, that's 2x. So we've done that part. Now let's try this part. 5 times x plus 5x, and now 5 times 2. Plus 10. And from here, right, we have some like terms. This and this, right, these are like terms. And like terms can be combined. So this would be simplified into x squared plus 7x plus 10. Now let's try another one, and we're going to try to use the distribution method to solve this, right? This is called the distribution method. And you can pretty much count on a paper test on this next couple sections, just because I know there's computer programs that will do this very easily, but you'll have to be doing it and demonstrating that you know how to do it by hand, because everyone can type in the computer. So we've got to be able to determine that you know how to do this by hand. So if we distribute, right, we're going to use this first term. It's going to be 2x times x plus 3. And then the second part, right, it says a plus. So it's going to be plus something. Plus what? Plus 4 times x plus 3. So you have basically distributed this and this to the parenthesis x plus 3. Now let's do the work. 2x times x, 2x squared, right? This is x to the 1 and x to the 1. And then 2x times 3, 6x. And then here we go, 4 times x, 4x, 4 times 3, plus 12. And these are like terms. 4 plus 6 is 10x. And then everything else I cannot combine. 2x squared plus 10x plus 12. So I don't know, the distribution method is not that difficult. What if we tried to line this up with algebra tiles? I'm going to try that right now. So let's take this algebra tile method, right? And on the top, I would have basically x and then plus 3. And on the bottom here, or on the left, I should say, well, I'd have an x, I'd have another x, and then I would have 4 of these things. So let's see what we got. Well, the x and the x, that would make an x squared. And that would make an x squared. And then we would get an x, x, an x, an x, an x, an x. Here's another x, another x. And then, right, you would get something like 12 little boxes. So I just want to illustrate that you can also do these with the algebra tiles, right? How many of these things do I have? Right, 2 of them, 2x squared. And then how many of these things do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them, 10 x's. And then I think you kind of already know, right, that you have 12 of those. So here you go. There's just 2 different ways, and we're just going to learn a couple different ways. And that's kind of the beauty of some of this mathematics, is there's really not a certain way to do it. It can be done many different ways, but you'll see we come to the same conclusion in either way. So we're going to learn another method now called the FOIL method. And FOIL, I don't know why I wrote a P there. FOIL, this is the way they've been teaching for, I don't know, they used to teach this when I was a kid too. So a long time, because I'm old. Right? FOIL stands for first, outside, inside, and last. And they actually teach this to you kind of last because they find it's probably the least effective, or at least it's the most prone to errors. People make a lot of mistakes when they foil, and that's why we're trying to show you a couple other different ways that also work and maybe less prone to mistakes. So when we foil, right, if we consider the first or the F part of foil, right? That's the F part of foil. What that looks like, here we have x squared plus 3 times x plus 2. What they're talking about when they mean the first is they want you to take the first terms and multiply those together. And so if I take that first term and multiply it together, right, this is like x squared times x to the first, I would get x to the third. And then the next part of foil, the outside, or the O, if you will, is now they want you to take this same first term and multiply it by this outermost term, or the outside term. So x squared times 2 is going to give me 2x squared. And then up next, right, if I do inside, or the I part of foil, what they're talking about is now this inside term, I guess the intersection of what you're multiplying, the middle, so to speak. That's 3 times x to the first. And 3 times x is 3x. And then last, right, they literally mean like now you got the last thing to do is take that inside term and multiply it by that last term. And, right, or the L part of foiling is basically 3 times 2. And what is 3 times 2? It is 6. So combined, your answer now is x to the third plus 2x squared plus 3x plus 6. And that's foiling. And it's a little bit different than distributing, but the actual steps and results are not that much different. So we're going to try some more examples of foiling. So let's give this next one a shot. Right? If I do the first term, that's basically 3x squared times x. Right? This is my F of the foil. And that's 3x to the third. And then I go, remember it's first and then outside. So that's 3x squared times 5. And that's 15x squared. And this is the O. Now I have to do the inside. Minus 2x times x, and that's going to be minus 2x squared. That's the inside part of foil, right? And now the last term, right? Negative 2x times a positive 5, negative 10x. So you've got all your first, your outside, your inside, and your last. Combined, your answer is 3x to the third plus 15x squared minus 2x squared and minus 10x. And you are almost done. But you have to combine these terms, right? Plus 15 and minus 2. So your final answer is this. Now, you could take a problem like this, and now this has, instead of 4 terms, it's got 5 all combined. And you could FOIL this out, and it would be a lot of computations, but you might make a few errors. So they recommend that you try the distributive property on something like this. And the way that works is basically I'm going to take x, I'm going to multiply it by x squared. I'm going to take x and multiply it by the negative 5x. And then I'm going to take x and multiply it by 4. And then I'm going to add to that two. Let me see if I can write this in a different spot. I'm going to add to that 2, right? 2 times x squared, and then plus 2 times the negative 5x plus 2 times that last term of 4. So now that we've distributed both the x and the plus 2 to everything in the inside the second parentheses, well, let's see what we have. So this is x to the first and x squared, right? Combined, that makes x to the third. These two, when multiplied, right, you get basically a negative 5x squared. These two, when multiplied, plus 4x. These two, when multiplied, that's 2x squared. So I'm going to just set them up vertically. 2x squared. These two, when multiplied, that's negative 10x. So I'm going to work vertically there as well. And then 2 times 4, basically plus 8. So let's combine all our like terms. Right, this just carries down. X to the third minus 5x squared plus 2x. You've got negative 3x squared plus 4 and minus 10 minus 6x. And you'll kind of notice that setting things up vertically just kind of helps eliminate a lot of possible errors you could make when you're setting these up in a line. It's better to work down and vertically on stuff like this. Now let's go to the next example, and let's do the distributive property again. So you basically have 3x times a negative 2x, I think that says squared, plus 3x times 5x plus 3x times a negative 6. And then you also have minus 4 times a minus 2x squared. You have a minus 4 times 5x. And you have a minus 4 times a negative 6. So now let's just see what all these things make. Right? When I combine this and they're multiplied, I'm going to move the work over here. Well, 3 times 2 is 6. And x to the first and x squared is x to the third. But it's 3 times a negative 2. So it's negative 6x to the third. And then 3 times 5, right? We're doing these two now. 3 times 5 is 15. And 2x's is x squared. Now I'm doing these two. 3 times negative 6, negative 18, but with an x. Now I'm going to do these two. Negative 4 times a negative 2, that's positive 8, but positive 8 squared. I'm doing these two. Minus 4 times 5, minus 20 with an x, and I'm setting this up already vertically for my eventual combination of like terms. Minus 4 and minus 6 plus 24. So let's add all these together now. Negative 6x to the third plus 23x squared minus 38x plus 24. So that's another example of using the distribution method. And I don't know, I kind of like this way the best. It seems like the neatest and least likely to make an error. And it just kind of all wraps up in a clean way that is easy to understand. And why make things harder on yourself if you don't have to? So there's that way. This distribution method, though, also works pretty well with this concept of setting up basically a graphic organizer for your multiplication. And the way it works is it works a lot like the algebra tiles. You're multiplying. So maybe instead of x there, because I don't want to confuse anybody, right? We are multiplying. And I'm just going to list my terms. And it's pretty easy to make a grid. And you put the terms in the grid like so. And then I have a 4x here, and I have a minus 7 there. And this is a lot like the distribution method, but it's another way you can also kind of give some order or organization to multiplying polynomials. So in the first box, it's basically 4x times, it's like this one times this one. So 4x times x squared is going to give us 4x to the third. And then this 2x right here is going to be multiplied by the 4x. And then that's 8x squared. And 3 times 4x is 12x. And then on the bottom part, minus 7 times x squared, minus 7x squared. Minus 7 times 2x, minus 14x. And minus 7 times a positive 3, minus 21. And I don't know about you, but this makes a pretty neat presentation as well, and easy to understand. I can only combine these terms, and then I can simplify. So my answer is 4x to the third, and then this is basically 8 minus 7. So that's plus 1x squared. Oh, and we can combine, shouldn't say that was the only thing we can combine. We can combine this one and this one, right? And I can combine those two. Minus 14 and plus 12 is minus 2x minus 21. So there you go. And that's just, taking something that looks complicated at the beginning, and really it's just a series of small steps that you do and combine.